Well, greetings, Mr. Colazar's class. Today we're going to talk about section 10.2 in your chapter notes. Thinking back to section 10.1, we went through and went with the idea with particles to moles or moles to particles. Today we're going to start looking at mass to moles or moles to mass, needing our periodic table. So make sure you've got your gold packet and your periodic table ready to go. We will need your gold packet today. So make sure you've got that gold packet ready to go. So what we're going to be looking at today is a mole always contains the same number of particles, but their masses can be different. So our focus for today is looking at the idea, if you have 1 mole of carbon and 1 mole of iron, they contain the same number of atoms but a different amount of mass. And so if we were to look at that, reason why, even though you have the same number of atoms in 1 mole, 6.02 times 10 to the 23rd, their composition is different. The number of protons and neutrons are different. So those will be kind of our two key parts there. So when we look, an example would be if you have 1 dozen tennis balls versus 1 dozen or 12 ping pong balls. Sorry about that. That they have the same number to each one, but they have different mass. So the mass is different between them. So just because you have a 1 mole, same amount material wise, but their composition is different, their masses would be different between those two. So using mass can be used to determine the amount of matter. So an example is, let's say you had a jar of candy. So if you had some candy, some M&Ms or jelly beans in a container, you just got a bunch of candy in a container. If we knew how much the mass of the container was, we could actually use that mass of the container if we know the mass of the jelly beans. And maybe we know the mass of 1 jelly bean. We could use that to find out how many jelly beans total we have. So that'll be kind of one of those concepts that we're going to be looking at, is figuring out how much material or matter we have. Our key one is, though, we're going to talk about molar mass. Molar mass is going to be the mass in grams of 1 mole of any substance. And this will be our key one that we're going to look at putting in with that molar mass, is to add this in. 1 mole of X equals that number of grams of X using our periodic table. So this mass is from the periodic table. So let's make sure we've got that one in our notes. 1 mole of whatever substance, X, equals that many grams on the periodic table. So if you have a mole of it, you're going to have that many grams of it. So to look at that, using your periodic table, the mass number equals 1 mole of that substance. So if you have 1 mole of carbon, sorry about that, is going to equal 12.01 grams of carbon. Or for oxygen, 1 mole oxygen would equal 16.00 grams of it. So for any substance on the periodic table, that molar mass, 1 mole of that element equals 1 mole, or the amount of mass in grams equals 1 mole. So that's going to be kind of our key part. So looking at that, the molar mass of any element given on the periodic table is numerically equal to the atomic mass given on the periodic table. So molar mass has a unit of grams per mole, which is the number of grams in 1 mole of a substance. So what we're looking for is we will have two different types of units here, grams per mole, or we'll be looking at atomic mass units. This part's not in your notes, but what we're looking at is, example, if you had iron mass of 55.85 atomic mass units, what is the mass of 1 mole? Just to look through, if you had, this is actually a Avogadro's number, 1 mole to atoms, you could take how many atomic mass units per 1 atom, and this is the mass of 1 atomic mass unit. We could find out that the mass of iron would equal 1 mole of iron. So that's just something extra that's not in our notes. But what is in our notes, according to the periodic table, an atom of iron has an atomic mass of 55.85 atomic mass units. So on the periodic table, that's how much 1 mole of iron would be. Molar mass, this is if you had 1 atom. Whoa. So if you have 1 atom, that's how many atomic mass units you have. Molar mass of iron, 55.85 grams. So if you measured out 55.85 grams of iron, you'd measure out 1 mole of iron. So 55.85 grams would equal 1 mole if you were to weigh that out. You would also have 1 mole or 6.02 times 10 to the 23rd particles. So our number of moles is becoming very important there. So in the box that you have in your notes, converting between moles and molar mass is going to be our new conversion. So 1 mole of anything on the periodic table is going to be used to measure out grams on the periodic table. So our two conversions using the periodic table atomic mass, 1 mole of X, whatever that is, over the number of grams from the periodic table for that substance. Or our other conversion would be just the opposite, your grams from the periodic table over 1 mole of X is going to be our key part. So we're going to use the periodic table to find that molar mass for our conversions. So what that's going to look like is when we analyze the problem, I think it's written just backwards for you. What is the mass of 3.00 moles of iron? For instance, it has a molar mass of 55.85 grams per mole. Iron can convert from mass to moles. So when we look at this problem, we're starting out, we're going to analyze. We have a certain mass is what we're trying to find, and we know we have 3 moles of a substance. So to solve for this problem, our first step is we've got 3 moles of iron. So we know we have a certain amount of iron. We're trying to find the mass. To go from moles to mass, we need to use the conversion using our periodic table. 1 mole of a substance is equal to 55.85 grams of a substance. From there, we can take moles to cancel moles, leaving us in grams. 3 times 55.85, making sure we keep with the 3 sig figs, allows us 168 grams of iron. So if we wanted to, weighing out on the periodic or on the balance, you could weigh out this mass, and it would equal the same as having 3 moles of iron. Another problem we'd like to go is just the inverse. How many moles of iron contains 75 grams of iron? So to analyze this problem, our first step, we start out, we know we have 75 grams of iron and want to get to moles. If our starting point, 75 grams of iron, 75 grams, we want to go from grams to moles. This time using our periodic table, 55.85 grams over 1 mole, setting it up so our units can cancel. Grams cancels grams of iron, leaving us with moles of iron. 75 divided by 55, we end up with about 1.34 moles of iron in the end. So to look over and to box our answer there. So in the end, 75 grams would be the same as 1.34 moles of iron. So we will stop here for now and finish up in class the other problems. Just to end us for today, got a little guacamole. In order for us to make some guacamole, our ingredients for one bowl of guacamole, 6.02 times 10 to the 23rd avogadros, instead of avocados, to get our guacamole for today. Safe travels to everybody. We'll see you in class.